Okay, hello Trig students. We are starting on the very last chapter or partial chapter that we have to cover. This is section 9.1 and it is all about vectors. Now, this section is a long one. So I think last time I looked, I think it was 51 points or something. So this is a big assignment. And kind of new. The beginning is really easy. The end part is not so easy. So please take a listen and look here. Um, let me dive in. This one's probably going to take several sections to get through, several different videos. So this is the first one, part A here. Vectors in 2 dimensions. Now, this first part of vectors, here are the first several problems. Essentially, we're just dealing with drawing a vector in an XY plane or a Cartesian plane or rectangular coordinate system, whatever you want to call it. And we're looking at, the change in position. Essentially, they call it displacement, but the change in position, the horizontal versus vertical. And anyway, also though, towards the end of this lesson, when it gets more into applicable word problems, we're talking about when we usually use vectors, it's for magnitude and direction. Okay, so I'll show you that when we get there, but this is vectors. So let's dive in here. It says sketch the vector indicated. The vectors u and v are shown in the figure. Now, they want 2u. Well, what does that mean? Essentially, these are starting at the origin. You can tell by the picture. And then you can actually identify a vector. Again, it's almost like an ordered pair based on its components. And here's what component form is. For this vector u, and they kind of use, that's of course my dead spot on the board, they kind of use, it almost looks like a less than or greater than symbol. If you go to answer some of these, you'll notice there's a vector tab on the right. And so you'll need to pick out the vector symbol here. It's not the less than and greater than symbol, but it kind of looks like it. So this vector u in component form, we went 1, 2, 3, 4 places to the left, and then we went up 2 places. So this would be the component form of vector u. Well, if we're going to find 2u, then literally we multiply both of those by 2. So it's going to be -8, 4. So to draw or to sketch my vector 2u, it's going to be 5, 6, 7, 8, and then up 4. So it's going to end here. It is literally twice the length of vector u going in the exact same direction. Okay, so twice the length of vector u going in the exact same direction. Okay, that's it on that one. Let's keep going. Sketch the vector indicated. The vectors u and v are shown in the figure. Again, I personally think the easiest way to do these is to first find the component form of each vector. So the component form of u is, again, we go 1, 2, 3, 4 to the left, and 1, 2, 3, 4, 5, 6 up. So -4, 6, that's component form for u. Component form for v, we're going to the right 5 and up 3. Whoops. I put a parenthesis. It's not a parenthesis. It's actually these little, like, they look like less than or greater than signs, but they're not. You're going to have to, again, pick them out of the vector tab on the right if you need them. But here, if we are subtracting, so I'm literally subtracting each of these 2 components. So that means u minus v is going to be a -9, 3, -4 minus 5, and 6 minus 3. So if I go to draw this, if I'm sketching, I go to -9 and up to 3. This is my vector u minus v. I hope that makes sense. To me, that's the easiest way. You can, if you look through the PowerPoints, which I thoroughly recommend that you do. There's a lot of information in the PowerPoint for this section, but they talk about drawing a parallelogram and which direction it goes, blah, blah, blah. To me, I like to think of them in terms of their component form, their horizontal versus vertical position, and then just do the math. I think that's the most straightforward approach, but that would be u minus v. Okay, next one. Express the vector v with initial point P and terminal point Q in component form. Okay, now on a vector, the initial point is obviously the starting position. Okay, the terminal point, terminal is like end. Okay, that's the end position. So all we have to do is count the boxes that it changed position. So how far to the left and up, or how far to the right and down, or how far to the left and down did it go? That's all you're doing, is talking about the change in position. So from the initial point P, we go 1, 2, 3, 4, 5, 6, 7, 8 to the left, and we go 1, 2, 3 up. So it would be a -8, 3. And again, you must use these brackets come from the vector tab on the right side of your screen. Okay, so those brackets, they are not less than and greater than symbols. They come from the vector tab on the right side of your screen. So keep that in mind when you're going to poke it in. Okay, so that's all you're doing, is looking at the change in position from where it started to where it finished. Next one, express the vector v with initial point P and terminal point Q in component form. Assume that each point lies on the grid lines, yada, yada, yada. Again, starting point, ending point. So again, we take horizontal and then vertical. So horizontal, it looks like we're counting by ones. So 1, 2, 3, 4, 5, and then vertical down. So first of all, we go 5 to the left. And then vertical, we go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that would be my vector. And again, you have to use the brackets from the vector tab. Okay, so it's just a change in position. We move 5 to the left and 10 down to get from P to Q. You have to look at the direction the arrow's pointing. Okay. Next one, sketch the given vector with initial point 5, 3. So first let's plot the initial point, 1, 2, 3, 4, 5, up 3. This would be my 5, 3, it looks like. Okay, and we have to sketch the given vector. U is -4, 2. So -4, 2. We're going to go to the left 4, 1, 2, 3, 4, up 2. This would be my end point. So this is my start. This is my stop. On a vector, you have to draw the segment with the arrow on the end, because on vectors have to have direction. Okay, so that's how we define vectors. So starting point to ending point. Starting point was 5, 3 that they told us, and then U here is to the left 4, up 2. That's what this is telling us. It's telling us left 4. This is telling us up 2. Okay, so then it says down here in the box, it says find the terminal point. Here we're just talking about an actual point on the Cartesian plane. So that would be the point 1, comma, let's see, how far did we go up? 5. I guess I should have been able to count there. 5 minus 4 and 3 plus 2. So that's our terminal point. Okay, I think those are easy enough to see. You're just talking position, direction. Sketch the given vector with initial point 2, 1. So again, initial point right here, 2, 1. And we're going down, sorry, not down yet. We're going left 7 and then down 4. So 1, 2, 3, 4, 5, 6, 7, and then down 4. 1, 2, 3, 4. Okay. So here's the vector. Again, you've got to draw It's like a segment with an arrow on the end because you have to go from the initial point to the terminal point where it ends. Okay, so this is our vector u. And again, if I find the terminal point, it should be a -5, -3, right? So 1, 2, 3, 4, 5, 1, 2, 3. And how did I get -5, -3? I actually added, this and this together. So my terminal point, -5, comma, -3. Okay, that's what you would put in the box. Easy enough. Okay, now write the given vector in terms of I and j. Okay, so we have component form. That's what we've been doing inside those little brackets, if you will, the little pointy brackets. Now, in terms of I and j is just, it's almost like X and Y, if you will, but I is your horizontal, J is your vertical, okay? So I is the horizontal, J is the vertical. Okay, so 1, 8 is literally 1i plus 8j, or just I plus 8j. That's it. That's all there is to it. Okay? So instead of doing, the left is the horizontal, the right is the vertical, now the horizontal is I, the vertical is j. That's all there is to it. This would be 0i plus a -7j, or just -7j. That's how we would write that. We would just drop off the I part if it's 0. Okay? Hope that's easy enough to see. All right, now, all we're doing is multiplying or adding or subtracting, whatever. So 2u, you are literally taking 2 times -8 and 2 times 1. Okay? That's all you're doing. So this is going to give me -16, 2. And it didn't tell us. I assume since they gave it to us in component form, they want the answer in component form. Yes, they do. I just looked. Okay. So -3v. You're literally taking -3 and multiplying it by each component of v. So this is going to give you -6, 24. Okay. U plus v. You're literally adding the corresponding components. So -8 plus 2, and then 1 plus -8. So you would have -6, -7. Okay. And then 3u plus 3v. Well, let's first figure out what 3u would be. So 3u, again, just going to go ahead and multiply each of those by 3. You'd have -24 and 3. And 4v would give you 8 and -32. Okay. So 3u multiplied the u times 3, 4v multiplied the v times 4, and then we subtract. So now we have to come through here and minus these. Okay. So -24 minus 8. What would that give us? -24 minus 8 would be -32. And then 3 minus a -32 would be 3 plus 32, or 35. Okay. I hope that's helpful. All right. I think we got one more of these. Now it's in terms of I and j. Okay. So it says also to simplify your answers completely, which means if you're going to have like a 0, then you just drop it off. You don't even write it. Okay. So 2u would just be 2i. Since u equals I, we're just going to take I times 2. -3v would be +6j. Again, it's -3 times -2j, which is +6j. 2u is 2 times I, which is 2i. Okay, u plus v. Again, we're literally just adding them together. This is I minus 2j, or really it's I plus a negative 2j. So plus a negative, we just drop the positive. And then 3u minus 4v. Well, this would be 3I minus 4 times negative 2j. Well, this is going to leave me with 3I plus 8j. Okay, I hope that's easy enough to see. All right, keeping going. Okay, now we've added direction and magnitude. Okay, in your PowerPoint, there is a formula that you need to know about the magnitude of a vector. And the formula looks like, let me get to it. I'm flipping through the pages. I want to use the exact same letters they do. So essentially, your magnitude of a vector, okay, is going to be the square root of your two positions. It's like it's almost like your I squared position plus your J squared position. Okay, so in this instance, your theta is 120 degrees. So let me draw you a picture. You all know I'm a picture person. Okay, so that's my XY coordinate here. So theta is 120 degrees. That means my vectors this and this to here is 120 degrees. Okay, now my magnitude of my vector, okay, this magnitude is 30. Now, again, let me go back and say, up until now, we've been dealing with vectors that just have a horizontal and a vertical direction. They were kind of like dipping our toe in the water of vectors, if you will. Now we're talking about vectors in application. And vectors in application in math have magnitude and direction. Magnitude can be force, it can be velocity. Those are the two that jump out at me probably the most, or force and velocity, and then the direction it's heading. So this has a magnitude of 30, okay? Now, what this means is if I take this and draw this down here, if that's 120, then that makes this 60, right? And so they're trying to find the horizontal and vertical components. We are trying to find the I and the J. That's essentially what we're trying to find, okay? So we have got to actually use some trig here, okay? So if we're trying to find I, 30 is like my hypotenuse, okay? Think of your magnitude as the length of your hypotenuse, which is essentially, I mean, that's what the formula is up above there. So we are looking to get I, okay? I, well, let's just say cosine, actually, let's say cosine 120. We'll go back to the 120. So cosine 120 degrees equals I over 30, okay? Cosine of 120 equals I over 30. Now, could we have used the 60? Absolutely. But you will get the same answer for 120, and it will give you a negative. So you don't really have to worry about what quadrant your degree is in. It's automatically going to give you a negative because we know cosine's negative in the second and third quadrant. So this means that I equals 30 times cosine 120. Well, now let's talk about J. Well, J is going to be sine. So sine of 120 degrees equals J over 30. Remember, sine is opposite over hypotenuse, where cosine's adjacent over hypotenuse. So this means then that J equals 30 times sine 120. And again, we could have used sine of 60, and we actually would have gotten the exact same answer because sine is positive in both the first and second quadrants. When we poke this in here, okay, cosine of 120 is -1/2. Okay, sine of 120 is √3/2. Okay, and you can just poke that in your calculator. All right, so your I is going to give you a -15. Okay, your J is going to give you a 30, well, actually the 2 will go into 30 15 times. Let's go ahead and reduce it. So we would have 15 √3, that's our J position. Okay, so when it says find the horizontal and vertical components, they literally want it in I and J form. Okay, so my final answer here would be -15I plus 15 √3J. Okay, so that is your horizontal position, that is your vertical position. Those are your components of your vector. I hope that made sense. I'm a picture person. So you've actually got a formula in your packet again, in your PowerPoint, that tells you that formula for the horizontal and vertical position. Okay. All right, let's do the next one. Same type of setup here. Let me scroll up just a little bit. So now we have, let me draw a picture. So now we have our theta is 300 degrees. Wow. Okay. So that means it's going all the way around here. Okay. That is 300 degrees, which means what's left here is just 60, right? So again, a couple different ways you can do this, but our vector, the length of our vector, let me extend this a little bit. Length of our vector here, the magnitude is 5 √3. Okay, so if I want the horizontal and the vertical position, horizontal, and actually let me label this up here. This is horizontal, is your cosine. Okay, your vertical is your sine. Okay, so horizontal position, and our horizontal, remember, is going to give us our I. Okay, our vertical, remember, is going to give us our J. Okay, so horizontal position, we take the magnitude, actually you take the absolute value. If you look at the formula on your in your PowerPoint packet, it's the magnitude, which is positive when we talk magnitude. The magnitude times cosine of theta I plus magnitude times sine theta J. Okay, so first one here. This would be, our magnitude is 5 √3 times cosine 300, and that's going to give us our I value. Okay, 5 √3 cosine 300, that gives us our I. I actually need to poke that in my handy dandy calculator here. I didn't pre-solve this one. Now, also, before I forget, make sure on your calculator that you're in degree mode on this. Okay, these are more like real world problems, so almost all of these, actually I would probably go so far as to say is all of them are in degrees. So make sure your calculator is in degree mode. So cosine of 300 is going to give us 1/2. Okay, that is 1/2 times 5 √3. So 5 √3 over 2I. Okay, for our vertical part, it is 5 root 3 times sine of 300, and that's our j part, okay? So we do sine of 300, that's where we're going to get the negative root 3 over 2, because sine, remember, is negative in the fourth quadrant. So negative root 3 over 2, okay? This is going to give me, remember, root 3 times root 3 is just 3, negative 15 halves j, okay? Everybody okay with that? Now, that's what goes in my answer then. I just add them together, or in this case, subtract since j is negative. But I'd have 5 root 3 over 2 I minus 15 over 2 j. That would be my answer. Okay? Hope everybody's okay with that. Okay, moving on. Find the magnitude and direction in degrees of the vector. Assume that theta, which is measuring our degrees, is between 0 and 360. Round the direction to 2 decimal places. Okay, so we have, first we have to find our magnitude, okay? The absolute value of v. So absolute value of v, remember in our component form, this is like my a, this is my j, or my a, my I, 15 is my j. So the magnitude of v is going to be the square root of negative 8 squared plus 15 squared. Okay, you poke that in a calculator and you get magically 13. Yay us. Okay, so this is a nice, neat, even 13. Now, if I go to draw this, okay, because then they want the direction. So again, I'm a visual person here. So if my vector is a negative 8 and 15, it's going to be somewhere up in here. Okay, here's going to be my vector. So this position is negative 8. This position is 15. Okay, there would be my right triangle. So what I'm trying to find then is this theta, because we always start from our initial point, the positive x-axis. Okay, so I'm trying to find my theta. So how can I do that? Well, I am first going to start by finding this x. Then I'm going to take 180 minus that to get my theta. Okay, so if I do that, then I'm just going to use tangent. So tan x equals, again, opposite over adjacent. Sorry, I was looking at something. And you know what? I wrote the wrong thing. Why did I write 13? That's why I was looking. This is not 13. That doesn't make any sense. Your hypotenuse is going to be longer than your side. I looked at a different problem. This is 17. I should have just poked it in my calculator from the start, I guess, and done it brand new. So tan x now, let me go back to that, is opposite 15 over adjacent negative 8. Okay, now if you do arctan, so x, remember, is arctan in your calculator, and you could either put it in as negative 15/8 or positive. It doesn't really matter. If you put it in as negative, it's actually going to give you a negative answer, which means you automatically, know that you have to subtract it from 180. But if you poke that in your calculator, you are going to get a negative 61.9275, yada, yada, yada. Okay, so in order to get theta, then theta is going to equal 180 minus 61.9275, okay, which is approximately 118.07 degrees, because they said 2 decimal places. Okay, so that's what goes in our blank, is 118.07. Okay. because we were trying to find theta again from the positive x-axis side. Okay. All right, let's do the next one. Now find the magnitude and direction in degrees of the vector, same exact problem. Okay, so first of all, magnitude, I'll try not to screw it up this time. Square root of 12 squared plus 5 squared. Okay, 12 squared plus 5 squared. This is the 13. This is what I looked at on the previous problem and wrote down the wrong number. So 5, 12, 13 is one of those Pythagorean triples. Okay, now, once again, we have to find the degrees. So if we're drawing this, okay, if my vector was a 12, 5, that's like over here somewhere, okay? So this position is 12, this position is 5, okay? And again, we are trying to find theta. This right here would be my theta, all right? So how do we find theta? Well, that's pretty easy. Again, tangent theta now would be opposite over adjacent, 5 over 12. And you could, you could use sine or cosine, since we now know too that this is 13. So it really doesn't matter what trig function you use. So then theta, of course, is the arctan of 5/12, which is approximately 22.62 degrees. Okay. And they've already got the degree markings, so you just have to put in the number. Okay. Hope that is helpful. Okay. I may stop here since we are going over 30 minutes. I'm going to stop here for now, and then we'll start in on the bigger word problems in the next section. Okay.